All right. Do you guys need me to go over problems 1 or 2? Number 2? Anybody at the board, you guys need me to go over 1 or 2? We're going over number 2. Do we need to go over number 1? Just number 2? Okay. Anybody need me to go over number 1, or is number 1 good? Number 1 is good? Okay, so we'll go over number 2. All right, so with number 2 is a little bit different than number 1. Number 1 had the -9 right next to the absolute value sign. What does it mean if it's right next to the absolute value sign? It means multiply, which means we would do division, right? That's how we would fix it. So number 2 is different because it's not written right next to the absolute value sign. So if it's not written right next to it, how do we move the -9? We add it. It is currently being subtracted. That's what negative means. -9 means it's currently being subtracted. So if we want to move it, we're going to add it over to the other side. So I'm going to plus 9 plus 9. So I have an absolute value of 1 plus 7k is greater than or equal to, what is 6 plus 9? 15. So here I have the absolute value symbol, and then my greater than, and then my number. Since my absolute value is all alone, this is where I can figure out what this symbol is called. So what is this called right here? Greater than, greater. Greater. So what kind of answer am I going to have? Or, which means my arrows look like what? They go, is it a sandwich? No. The arrows go opposite directions, right? One arrow goes to the left, one arrow goes to the right. So I'm going to say k is less than or equal to the smaller number, or k is greater than or equal to the bigger number. That's what our answers are going to look like. They're going to go opposite directions. Yes. Did you put it in to... Daniel, did you put it in? Can you put it in? Wait till Eddie comes back, and I need you to put it in. Okay. So we've got the format for the answer. And so what we're going to do now is we're going to figure out what the two answers are. So I'm going to have 1 plus 7k equals positive 15. And I'm going to have 1 plus 7k equals negative 15. Positive version, negative version. So if I go about solving these, what do I have to do? I have to subtract the 1. So minus 1, and then minus 1, minus 1. So for the first equation, I have 7k equals what? 14. For the second equation, I have 7k equals negative 16. Okay? And so what am I going to do next to get the k alone? Divide. Divide by what? 7. Divide by 7. So for my first solution, what am I going to get? 2. K equals 2. For my second solution, I'm just going to leave this one as a fraction. And what's my fraction going to be? 16/7. You're very close. Negative 16/7. Okay, so between the two of these numbers, which one should go with the smaller part? The negative 16/7, because it's negative, the other answer is positive. So I'm going to put negative 16/7 right here, and then I'm going to put the positive 2 over here. Is it wrong if you switch these? It is wrong. Your answer is wrong if you switch those. You have to put the smaller number first, bigger number second. Your answer is wrong if you switch those. Okay. Do we need to go over the graphing ones, number 3 and 4? 3 and 4, do we need to go over the graphing ones? Are we good at graphing those on Desmos? We can do it? Yes? So we don't need to go over how to do those. No? We're good? Okay. Last one, transformations. What are the 3 transformations you guys can see? Reflect over X. Okay, what else? Okay. Left 5, up 3. Okay. X-intercepts, how do we do that? How do we find the x-intercepts? Does that just come from our brain or come from the equation? How do we find the x-intercepts? We type it in Desmos and we look on the graph. Okay, so I'm going to go ahead and get on Desmos here. So here I have already typed it onto Desmos, and actually on my answer key I put too much information because I think I put the y-intercept as well, and you don't need to because they didn't ask. So x-intercepts are -8, 0, and -2, 0. I had already graphed that problem. So -8, 0, -2, 0 are the 2 x-intercepts. Okay. What is the range? So we have the picture. It's upside down like this. Do we use x coordinates for the range or the y coordinates? Quentin, what do we use? X coordinates or y coordinates for the range? Quentin, why did I pick on you? You were right. Yeah, let's put that away. All right, so we're going to use y coordinates for the range. So we're going to look at the bottom of the picture. What number is the bottom of the picture?
3.
What number is this? -infinity, arrows pointing down. Okay. And then what number is the top of the picture going to be? 3, because we're using the y coordinate of the vertex. So bottom of the picture is the arrows, the top of the picture is the y coordinate of the vertex, all right? And so how are we going to use this to write our answer?
You do -infinity.
Mm-hmm. 3. So the infinity, yeah, the infinity always gets a parenthesis. The 3 gets a bracket. Why does the 3 get a bracket? Yeah, because if I go back to Desmos, I can click on it right there. So if the definition of the range is that it's numbers that are actually there, and I can click on this, I should include it in my answer, and a bracket means I'm including it. Okay, let's go ahead over here. Let's draw a picture. Increasing interval means that my stick figure is walking uphill. So where is my stick figure walking uphill, the left side or the right side? The left side. So here's my increasing interval. What number is a left arrow? -infinity. And then what number do I have up here for an x value? -5. So my increasing interval would be what? -infinity, -5. And then does -5 get a bracket or a parenthesis? Now we have to think about when he stands right up at the top, is he walking uphill or downhill? Neither. He's in between. So if he was walking uphill, we'd put a bracket. But since he's kind of neither, he's right at the very top, that's why we put a parenthesis. Does that make sense? Okay. All right. Any questions about anything on the warm-up? We good? All right. Let's take out the assignment from yesterday. Looks like this. Pew, pew, pew. No? Nobody? You should have done 1, 2, 3, and 4. 1, 2, 3, and 4. I'm sorry, you gotta wait. we have two sides of the piecewise function. We have the left side, and what do we have to remember when we do the left side?
It's negative.
You take whatever the version is that they gave you and you stick a negative in front of it. So here it already had a negative. That means we're going to add an extra negative in the front. So I'm going to put a negative in front of the negative they already had. Negative in front of the negative. And then I'm not putting the vertical lines anymore. I'm just putting parentheses. X plus 4 minus 3.
I got a question. Okay, so we did still do vertical lines. Does it matter?
No. As long as you don't treat them like vertical lines. Yeah, that's fine.
Okay, I was making sure because that's what I got on my paper.
Yeah, you're good. You're good. What does minus minus do? What does it become? It becomes a positive. So we really have a positive and then an x plus 4 minus 3. And what happens if you take a positive and you distribute it into parentheses? Does it change anything inside the parentheses? It does not. So inside the parentheses, we just had x plus 4 and we had a minus 3 on the outside of the parentheses. So now we're going to go ahead and combine like terms. 4 and the negative 3, and what does that give us? 1. Okay, so for the left side, all we have to do is take the equation, stick a negative in front of it, and then get rid of the parentheses. That's all we got to do, okay? So we're done with the left side. Now we have to do the right side. The right side says take the equation as it is. Don't add anything to it, just keep it normal. So I'm going to take the equation as it was. Negative x plus 4 minus 3. And then we're going to get rid of the parentheses. So what should I do to get rid of the parentheses? Distribute the negative. So I have a negative times an x and a negative times a 4. So that gives me negative x minus 4, and then I have the minus 3 on the end. And what is negative 4 and negative 3 together? Negative 7. Yeah, 7 negatives all together. So I have negative x minus 7. Okay, so the left side has an arrow that points left. The right side is going to have an arrow that points right. Okay, so when I write my piecewise function, I'm going to do this on the left side. I'm going to do this on the right side. So I'm going to say x plus 1 if, and negative x minus 7 if. And then this is where I do left side, right side. I say if x is left of, if x is right of. And then does anyone remember how we figure out what number you're looking to the left of, what number you're looking to the right of? It has to do with the vertex, but it's a specific part of the vertex.
So
It's
one in there is 4. It's going to be negative 4.
Yeah, so the vertex is negative 4, negative 3. Negative 4, negative 3. And the part of the vertex that we're looking at is the x-coordinate, because the x-coordinate is what splits things from left to right. X splits things from left to right. We wouldn't use the y-coordinate because y has to do with up and down. We're talking about left and right. So we're saying if you're looking to the left of negative 4, if you're looking to the right of negative 4. So to summarize everything we did, we said with the left side, stick a negative in front of it. With the right side, keep it normal. And then we said for the left side, you're left of the vertex. For the right side, you're to the right of the vertex. It is that same process over and over and over again. It's very repetitive. Okay, so let's walk through that process again. Number 6, we're going to do left side, we're going to do right side. Do our arrows. We're going to use our vertex to help us figure out where the x value is. So the left side says take the equation and stick a negative in front of it. So we're going to have negative of negative 1/3 times x minus 6 minus 2. And then what happens with the minus minus? Makes a positive. Okay, minus minus makes a positive. 1/3 times x. 1/3 x. 1/3 times -6. So we'll show that on our calculator. 1/3. 1 divided by 3 is 1/3. 1/3 times -6 is -2. So you don't have to know that off the top of your head, although it's fine if you can do that. 1/3 times -6 is -2. So 1/3 x minus 2, and then we have a minus 2 on the end. So what does that give me? -4. 1/3 x minus 4. So we have finished the left side. The left side is ready to go. How are we feeling about this part so far? Is there a part of it that is confusing, or is it just the fact that we had a fraction? -2 and -2? The negative in the beginning? Does it make sense that a negative times a negative makes a positive? Okay. All right, now for the right side, we don't change anything about it. We just write it down as it is. So -1/3 x minus 6 minus 2. So -1/3 times x is just -1/3 x. And then -1/3 times -6. -1/3 times -6. So you can do it in your head. You can multiply on the calculator. But you get +2 because we're doing a negative multiplied by a negative. So I get +2. And then I still have the -2 on the end. So what happens with the +2 and the -2? They cancel each other out. So those cancel. And for the right side, we end up with -1/3 x. Okay. So when we write this answer, we're going to do the left side, and that's going to have an arrow pointing to the left. We're going to have a right side. That one's going to have the arrow pointing to the right. Okay? So left side. If x, and then we do the left. So the left side equation, if x is left of. The right side equation, if x is right of. And then now we have to go to see what the vertex is. And the vertex is +6, -2. And which coordinate of the vertex do we use? We use the 6 because it's the x value. And down here it says x. You always do the opposite sign when you write it as a vertex. So if that said -6, you would write +6. And so we're just doing the same thing. We're just taking that opposite sign. Left, right. And then we do always make sure that one of these has an equal to. It doesn't matter which one. I forgot to do it for this. You could always do it on the top one. You could always do it on the bottom one. You could alternate. It really doesn't matter. as long as one of them has it. Okay, let's try the next side. Okay, so left side. So we're going to take the equation. We're going to stick a negative in the front. Now this one doesn't have a negative in the front to start with like the other ones did. So we're going to take this one and we're just going to stick a negative in the front and then we're going to write it down. Okay. And now we're going to get rid of the parentheses. So what should we do? Distribute. And what do we get? Plus 5 with a minus 4 on the end. And then what do we have? Negative x and a positive 1. So when we combine like terms, we had a positive 5 and a negative 4. And if you combine like terms, you get 1. And so the left side is done. Let's go ahead and do the right side. For the right side, you don't add anything. You just do it like it is already. So we're going to do x minus 5 with a minus 4. Now with this one, there's nothing in front of the parentheses. So if there's nothing in front of the parentheses to distribute, do you really even need the parentheses? No, we don't really need them. So I'm just going to get rid of the parentheses, and I'm going to write x minus 5 minus 4, because those parentheses are unnecessary.
I didn't rewrite it. I just wrote x minus 9 because I didn't see the point.
That's fine. That's fine. Yep. That's fine. So if we combine like terms, what do we get? Negative 9. Okay. So left side, right side. Okay. So y. We got our left side. We got our right side. Yeah, see how all the problems are the same? We're not switching the process in between. We're really just, it's very repetitive. Yeah. Yeah, once you get it, you go, okay.
I don't have enough space to write it in that
I know.
little tiny area, so I've been writing the answers in the graph.
That's fine. Yeah, that's fine.
I don't have enough room to graph. That's my workspace.
Yeah, that's fair. What's the vertex for number 7? 5 and negative 4, and then the coordinate we're using is the 5 because that's the x value. And then one of these needs to have an equal to, it doesn't matter which one. Yeah. One of them does. One of them needs it. It doesn't matter which one, but one of them needs it. Always. Yep. Yes. All right, let's do the next one. So how should we start?
You should start by putting negative. You have to do 2/3.
Okay, so left side, we stick a negative in the front. So negative 2/3 times 6 is negative 4. And then there's also the negative 4 on the end. So when we combine like terms, what do we get? Negative 8. Right, Quentin? Right, Quentin? Oh, hey. Oh, hey. Are they so easy they're getting boring? Oh, I said negative 4 and negative 4 is negative 8. And then, no, I was asking you to confirm that it was negative 8. Yeah, okay. All right, and then what do we do next?
Did we already do the right side?
We got to do the right side.
Yeah.
How do we do the right side?
2/3 and then x plus 6 minus 4.
Keep it like it is, okay?
And then distribute.
Distribute.
You're going to get 2/3 x plus 4 and minus 4. And then you're going to get 2/3 x.
So left side, right side. And then what's the number? What's negative 6? And so the negative 6 is coming from right here. Okay. I want everybody to try number 10. Everybody's going to try number 10. Number 10. Yes, number 10.